Imagine you open up your favorite smart assistant and ask it to do something simple. Order me a pizza. It sounds like an easy task for an advanced AI, but instead of a hot pie arriving at your door 30 minutes later, the assistant simply replies with a recipe for margarita and suggests you call a local restaurant. The problem is that a large language model is entirely isolated. It is a reasoning engine, a digital brain sitting inside a sealed glass jar. It can think, calculate, and speak, but it has no physical mechanism to manipulate the objects sitting right outside the glass. Despite their intelligence, modern AI models remain trapped inside their chat boxes. They are passive conversationalists, unable to reach out and impact the systems they describe. To give this AI hands, developers currently have to manually write custom glue code and API connectors for every single application it needs to touch. If you want an agent to access your calendar, your email, and your database, you have to write specific rules for each one. Scale that up to a corporate environment, and you are left building and maintaining 50 different hard-coded integrations. Compare that mess to a system where tools share the exact same input and output format, allowing the AI to understand any service it encounters through one single interface. To build systems that actually scale, developers have to stop reinventing individual brittle connections for every new tool and start building a standardized communication system. Before the modern internet, computer networks were highly fragmented. They required entirely different setups just to communicate between machines. HTTP solved that fragmentation by creating a universal request and response protocol. Suddenly, any web browser could talk to any server using the same shared language. The Model Context Protocol, or MCP, is the direct equivalent of that breakthrough for artificial intelligence, but there is a mechanical difference in how they operate. HTTP relies on fixed endpoints driven by a human click. MCP relies on dynamic tool discovery, driven entirely by the AI's internal reasoning. By acting as a universal middleware layer, MCP shifts AI architecture away from static data retrieval and into context-aware execution. Let's track a prompt like "book me a flight" through a live production architecture. The user's request enters the API gateway and reaches the agent service, the true orchestrator of the system. Looking at this architectural map, we see the agent service node take the request, package it with current context, and send that structured bundle to the LLM. The map expands to reveal the MCP layer below the LLM. This layer acts as a registry. It exposes external tools, like a live flight database, to the LLM, translating their unique API requirements into a strict data schema that the AI understands. This starts a continuous loop of reasoning, acting, and observing. The LLM decides to search for flights. MCP executes that tool call, and the resulting structured data flows back to the AI so it can figure out the next step. Because MCP handles translation and security, the AI chains a flight search, a calendar check, and a payment tool together without needing a human to pre-program the sequence. This plug-and-play architecture completely decouples the reasoning model from the tools themselves. In this diagram, we see how developers can snap new capabilities onto an agent. Granting access to a local file system, a vector cache, or live enterprise apps no longer requires rewriting the core application code. This enables developers to deploy autonomous data analysts that query SQL databases to find revenue trends, or AI dev tools that actively write, test, and deploy code. The primary task of an AI engineer is shifting. Instead of building custom API pipelines, they are now orchestrating high-level reasoning loops. MCP is the standardized layer that transitions an AI from a text generator to an actor embedded in a professional workflow. By providing a universal pathway for the model to communicate with external software, we effectively give the reasoning brain a way to control its digital hands. Just as HTTP infrastructure connected decentralized applications to servers, MCP connects artificial intelligence directly to the world. Interacting with an AI is becoming less about reading what it says and more about observing what it can do on our behalf.